So we are going to go from plain factoring to simplifying fractions with polynomials. And so we have 3 problems up on the board. I'm going to add some others, but first I want to start with something that is even more basic. So let's say we had a fraction. Let's say we had 15 over 20, and you are asked to simplify it. Well, is there a common factor that goes into 15 and 20? 5. So 15 can be written as 3 times 5 over 4 times 5. Now, since they share a factor of 5, well, what is 5 divided by 5? 1. So these will end up canceling out, and we'll end up with 3/4. So if you understand this idea, you understand what we're doing on this section. And so I'm going to shrink this, but I'm going to keep it, so you'll see the similarities. I'll stick it down here. All right, so let's start with our first problem. Our first problem, we have 4a minus 20 over a minus 5. So do we see any common factors? We have a factor of a minus 5, and then we have 4a minus 20. Well, we don't see another a minus 5 in the numerator. So let's look a little closer at the numerator. Is there something we can do with 4a minus 20 that will help us simplify it? Well, we could factor it because they both share a factor of 4. So 4a minus 20 can be factored as 4 times a minus 5. So we factor out the greatest common monomial. It's still over a minus 5. And look, what do you know? We now have, just like down here, we have a common factor that can be simplified. So a minus 5 divided by a minus 5 is 1, and we're left with just plain old 4. Now there's one last thing we need to talk about, which are restrictions. You know from grade school that your denominator cannot have a value of 0. You can't have a fraction with a denominator of 0. So what value of a would make this 0? Well, if you plugged in a 0, you'd have 0 minus 5. That's still negative 5. That's OK. You can have a negative number in the denominator. If a were 5, you'd end up with 5 minus 5, which is 0. And you can't do that. So you know that a cannot equal 5. And this is the answer for question A. For question B, the numerator and the denominator look very close, but they're not identical, are they? One is a positive, and one has a subtraction. So we're stuck with the same idea. We're stuck with having to factor the numerator, and in this case, we'll also have to factor the denominator. So what goes into 6x plus 6y? Well, 6. So we have 6 times x plus y. What goes into 6x minus 6y? 6. So we're going to factor out the 6, and we're left with x minus y. And so do we have any common factors? Well, we have 6. 6 is common to both of them. So 6 divided by 6 is 1. So we're just left with x plus y over x minus y. And our restriction here is x and y cannot be the same number. Because if x and y were, say, both 5, 5 minus 5 is 0, you can't have that. So x cannot equal y. And so this would be our complete answer.
Wait.
For question C,
So like 11 through 22? No.
for question C, we're asked to do the same thing. We don't have a common factor as it is, so we need to break the numerator and the denominator into its factor pieces. So what goes into 8 n squared minus 72. Well, 8 goes into both of them. So we get 8 times n squared minus 9. Uh-oh. This looks like something we can factor again. In fact, what is it? It's the difference of squares. So to factor n squared minus 9, we end up with 8 times n plus 3 times n minus 3. I'm making the bold assumption that you remember how to factor a greatest common monomial. And then our denominator, we have 4n minus 12. Well, what do 4n and negative 12 share? Well, they both share 4. So I can factor out the 4. And I'm left with n minus 3. So now it's time to look for common factors. Do I have any common factors? Well, yeah, I have n minus 3 and n minus 3. So they can cancel out. N minus 3 divided by n minus 3 is 1. But I can also reduce this 8 over 4. 4 goes into 4 once. 4 goes into 8 twice. So I'm left with 2 times n plus 3. And now it's time to look for restrictions. Is there a number that I could substitute in here for n to make this 0? Well, 3 minus 3 is 0, right? So n cannot equal 3. And this would be your final answer. So now let's move on to some questions that are a little more difficult. So this next question, we're going to have to do something a little bit different. Let's say we were to have x minus 4 times 3x plus 4 over 4 minus x times 5x plus 2. So let's say we were to have this. Now, we already have both of these terms in factored form, which is a good thing. But we notice that none of their factor forms are identical, are they? We have opposites. We have x minus 4 and 4 minus x, which is going to be helpful. So what we can do is we can change these signs. Now, how do you change signs? How do you make something negative turn positive? How do you turn something that's positive turn negative?
Multiply by negative 1.
You multiply by negative 1. So I'm just going to look at this one piece here. I'm going to have 4 minus x. And what am I going to do to it? Multiply it by negative 1. So I'm going to multiply this by negative 1. And what do I get? I get x minus 4. But here's the thing. X minus 4 is not the same as 4 minus x, is it? No, it's not. So what can you multiply a fraction by that doesn't change it? Well, you can multiply it by 1, right? So if you're multiplying a piece of this by negative 1, that means you're also going to have to make this whole denominator negative, because that's how you changed it. So in other words, if I have a negative sign out here, and I were to distribute it, negative 1 times x gets me negative x. Negative 1 times negative 4 gives me positive 4. So 4 minus x is equivalent to negative x minus 4, right? So I'm going to use this piece instead of the original in the problem. So if I rewrite this, I have x minus 4 times 3x plus 4 over, and now I'm going to use this piece instead, x minus 4 times 5x plus 2, just grabbing it from the original problem. Do I now have common factors that I can factor out? Well, yeah. I have x minus 4 in both the numerator and the denominator. So I can cancel these out. So I'm left with 3x plus 4 over, negative 5x plus 2. But here's the thing. I have a positive divided by a negative, right? Well, positive divided by a negative is it's negative. So really, this whole thing is negative. So this is equivalent to 3x plus 4 divided by 5x plus 2. But as you already pointed out, the whole thing is negative. And there we have it. So that is the basic way, the fundamentals of simplifying fractions when you have polynomial expressions. Obviously, they can get more complicated, but this is the basics of how to manipulate these problems to get to an answer.